بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 9 algebra geometry. We are in model 2 angles and geometric figures. Today we have the third lesson, two-dimensional figures. At the first, I want to show you some videos about this idea.
This is Mr. Hardesty. Let's calculate perimeter and area in our next geometry example. Find the perimeter and area of triangle ABC. If A at -2, -2, B at 6, -2, and C 4, 1. Triangle ABC has been graphed on the coordinate plane. We're first to calculate perimeter. Perimeter is the sum of the lengths of the sides of the figure. So we'll take the length of AB and BC and AC and add those together, and then we'll have the perimeter. We'll begin with AB. AB, from here to here, we can simply count the squares since this is a horizontal line. That length is 8 units. Next to BC. BC, from here to here, we'll need to use the distance formula. The distance formula is the difference of the x-coordinates squared plus the difference of the y-coordinates squared. Then we take the square root of that sum. We'll substitute the values for BC. The x values are 6 and 4, so we'll have 6 minus 4 squared. And the y values, -2 and 1, so -2 minus 1 squared. This would be the square root of 2 squared plus -3 squared, which is the square root of 4 plus 9, so the square root of 13. As an approximate answer, we get about 3 6/10. So there's the length of BC. Now for the length of AC, the last side of our triangle, from -2, -2 to 4, 1. The distance formula will help us again. And we'll now substitute the x values and the y values using the same formula. So the x values are 4 minus -2, and the y values are 1 minus -2. Simplify, we have 6 squared plus 3 squared, so that's the square root of 36 plus 9, which is the square root of 45, which is approximately 6 7/10. So now we can calculate perimeter. That is, consider that the perimeter, the sum of the three sides, we can now express as 8 plus the square root of 13 plus the square root of 45. That would be our sum and radical form. If we substitute our decimal approximations, this sum is approximately equal to 18 3/10 units. Now we also need to calculate the area of our triangle. The area for a triangle is always 1/2 the length of the base times the height. 1/2 base times height. We can calculate the base quite simply by counting. Again, this segment AB, we counted its length when we did perimeter, is simply 8 units, and that's the length of our base, little b. Our height we can find by this perpendicular distance from point C to segment AB, and we'll label that H. And again, we can count 1, 2, 3 squares for the height. Now we'll multiply 1/2 8 times 3, which is 12. So the area of our triangle would be 12 square units.
This is the first idea. The second idea, transformations in the plane.
This is Mr. Hardesty. In our next problem, we'll take a look at transformation. Identify the type of congruence transformation shown in the diagram as a reflection, translation, or rotation. In our figure, we can see a tree, and opposite from that, in the water, is the reflection of that tree. How do we know? Somewhere here is the shoreline, which is considered as the line of reflection. That is, all points in the original figure are equidistant from the shoreline in this direction and in this direction. Perhaps this point at the top of the tree we could compare to this point at the top of the reflected tree. That distance to the line of reflection will be the same for those 2 points, and that would be the same for all points. So this is an example of reflection.
Hi, this is Mr. Rutherford. In this problem, we will learn to identify congruence transformations. Identify the type of congruence transformation shown as a reflection, translation, or rotation. Notice here in the first figure that each vertex, and I'll compare this vertex here and its corresponding vertex, notice that we have shifted this vertex 3 units to the left and 2 units down. And this is consistent with the other vertices. So because of this, we can say that this transformation is a translation. Now let's look at the second figure. Notice here that each vertex and its image are the same distance from the origin. So we'll compare this vertex and this as well. They're the same distance from the origin, and we can also say that the angles formed by each pair of corresponding points and the origin are congruent as well. Notice that these angles here, when connected with the origin, are congruent. So because of this, we're going to say that this is a rotation. In the third diagram, notice here that each vertex and its image are the same distance from the x-axis. Here's the x-axis. Now let's compare this vertex here and its image here. Notice they are both 1 unit from the x-axis. So because of this, this transformation is called a reflection. Hi, this is Mr. Rutherford.
This is Mr. Hardesty. We're going to work on reflection as it deals with the x-axis using coordinate geometry. Quadrilateral AXYW has vertices A, -2, 1, X, 1, 3, Y, 2, -1, and W, -1, -2. A. Graph AXYW and its image under reflection in the x-axis. Compare the coordinates of each vertex with the coordinates of its image. AXYW is already graphed as a quadrilateral. To reflect it across the x-axis, all we have to do is change the y-coordinates to their opposites. That is to take the inverse. Point A is graphed at -2, 1. We will graph its reflected point and call it A prime to represent the new point. Keep the x value the same. Take the inverse of the y value, so +1 becomes -1. And then we'll do the same for all of the coordinates of the quadrilateral. Point x is at 1, 3. We'll find point x prime and make it 1, -3. Change the y-coordinate to its opposite. Point y is at 2, -1. Its reflected point we'll call y prime, and it will be at 2, +1. And finally, point W is at -1, -2, and W prime is at -1, +2. Now we'll plot all 4 of our new points and build our reflected quadrilateral. A prime is at -2, -1. Plot the point and we'll label it. X prime is at 1, -3. Y prime is at 2, 1. And W prime is at -1, 2. Now we'll connect all of our points and build our quadrilateral that will be the reflected quadrilateral in relationship to the original AXYW in the x-axis. Part B. Graph AXYW and its image under reflection in the origin. Compare the coordinates of each vertex with the coordinates of its image. In Part A, to
This is Mrs. Dawson. Translations in the coordinate plane. Graph each figure and its image along the given vector. Triangle XYZ with vertices x, 1, -3, y, 3, 1, and z, 5, -5, with vector -4, 3. Quadrilateral ABCD has vertices A, 1, 1, B, 2, 3, C, 5, 4, and D, 6, 2, with vector -2, -6. Let's begin with the original triangle XYZ. XY will have a translation of down 4, so that would be the same as X, and then adding a -4, and a translation of 3 units up. So the Y value will be increased by 3. Vertex X, which is at 1, -3, will be translated to X prime, which is located at the ordered pair where the point -3, 0. And that's because 1 plus -4 is -3, and -3 plus 3 is 0. So the original point X is at 1, -3, and X prime is located at -3, 0. Vertex Y, originally located at 3, 1, is translated to Y prime. 3 plus -4 is -1, and 1 plus 3 is 4. So the original point of 3, 1, 1, 2, 3, 1, which was Y, is translated 4 units left and 3 units up. And that's located at -1, +4. This will be Y prime. Z, which was located at 5, -5, translates to Z prime, and the new ordered pair will be 5 plus -4, which is 1, and -5 plus 3, which is -2. So the original Z is at 1, -2. Oh, excuse me, the original Z was at 5, -5. 1, 2, 3, 4, 5. 2, 3, 4, 5. And once we've applied the translation for the vector, we have Z prime located at 1, -2. So the original triangle, X, Y, Z, the image is X prime, Y prime, Z prime. We'll work with the quadrilateral ABCD in a very similar fashion. XY will become X plus a -2 and Y plus a -6. And that's a translation of 2 units to the left and 6 units down. So A, which was located at 1, 1, becomes A prime, And the new point is -1, -5. That's 1 plus -2 is -1, and 1 plus -6 is -5. So A from 1, 1, it's translated to -1, -5. 1, 2, 3, 4, 5. And that would be A prime. B, which was at the coordinate 2, 3, becomes, or translates to B prime, which would be 0, -3. 2 plus -2 is 0. 3 plus -6 is -3. So B, 2, 1, 2, 3, goes to B prime. 0, 1, 2, -3. C, which was 5, 4, the image will have the point C prime at 3, -2. 5 plus -2 is 3. 4 plus -6 is -2. 1, 2, 3, 4, 5. 1, 2, 3, 4. There's C. And then C prime, 1, 2, 3, 1, 2. And then the last point, D, was originally 6, 2. So once the translation vector has been applied, D prime is 6 plus -2, which is 4, and 2 plus -6 is -4. So 1, 2, 3, 4, 5, 6, 2. Here's D. And then the translation, left 2, 1, 2, down 6, 1, 2, 3, 4, 5, 6. We are at the point 4, 1, 2, 3, 4, -4. And that's D prime. So if we connect all the vertices, you can see that quadrilateral A, B, C, D has been translated to A prime, B prime, C prime, D prime. And that's a translation of left 2 and down 6.
Welcome to McGraw-Hill Personal Tutor. Triangle DEF has vertices D, -4, 4, E, -1, 2, and F, -3, 1. Graph the figure and its image after a clockwise rotation of 180 degrees about the origin. Then give the coordinates of the vertices for triangle D prime, E prime, F prime. Let's go ahead and graph the original figure, the pre-image DEF, and we have D is -4, +4, so I'll go left 4, up 4, and let's go ahead and label that with our letter D. Then we have E, which is -1, +2, so left 1, up 2, and F is -3, 1, so -3 would be to the left 3 and up 1. So let's connect those vertices. Now it says that we're going to do a 180 degrees rotation clockwise. Now, if we are going to rotate about the origin, so our center of rotation is going to be the origin, 180 degrees can go either direction, either counterclockwise or clockwise. They'll end up in the same position. One thing to keep in mind is that with a 180 degree rotation about the origin, which is what we have, The transformation notation is xy maps to negative x, negative y, or the opposite of x and the opposite of y. So that's how we can do this problem. So when we compare our preimage points, which are d, which is negative 4, 4, that's going to map to d prime, which will be the opposite of negative 4 is 4, and the opposite of 4 is negative 4. So we'll plot that. So 4 will be right 4, and then down 4. And that will be d prime. Now let's go to E. So E was negative 1, 2, and that will map to E prime, and the opposite of negative 1 is 1, and the opposite of 2 is negative 2. So we'll plot that, so to the right 1 and down 2, and label that E prime. And our last point, F, which in the preimage is negative 3, 1, is going to map to F prime, and that's going to be 3, negative 1. So to the right 3, down 1. Now we'll go ahead and connect those. And so there is our rotation of 180 degrees about the origin for triangle DEF. Thank you for using McGraw-Hill Personal Tutor.
As you see in this question here, find the perimeter or circumference and area of each figure if each unit on the graph measure 1 centimeter. Round answers to the nearest tenth if necessary. In the first example here, as you see here, we have circle. Here x-axis and here y-axis. And we want to find the perimeter. If we have triangle, we have square, we have quadrilateral, or any shape without the circle. But the circle, we can use circumference. Circumference. So for the circle, as you remember, circumference equal 2 times pi times r. 2 times the value of pi, about 3.14. R means the radius, the distance between the center of the circle and any point from circumference. This is the circumference of the circle. The line who draw the circle about the center. So we want to find this distance. We want to find this distance. We can use the rule of the distance and the root squared x2 minus x1 squared plus y2 minus y1 squared. Here A, here B. This is here, for example, x2, y2, and here x1, y1. So x2 means 5 under square root 5 minus x1 will be 2 squared plus y2 means 3 minus y1 will be 1. 5 minus 2 will be 3. 3 squared means 9. And 3 minus 2 will be 3 minus 1 will be 2. 2 squared means 4. So the distance means the radius equal 9 plus 3, 9 plus 4 will be 13. So approximately we can find the square root of 13 equal about, here we have 2 times 3.14, and here we can use the calculator to solve approximately what is the square root of 13, about 3.6. Then we can multiply the all products here. We have 2 times 3.14 times 3.6 equal about 22.60. This is for the circumference. Then we want to find the area. As you remember, the area of the circle equal pi times r squared. Pi means 3.14 times r will be square root of 13 squared. So means we have 3.14 times the square root cancelled, the square cancelled the square root. Means we have times 13. So the answer will be we have 3.14 times 13. The answer will be 40.82. The unit here will be unit, and the unit here will be unit square, because here we have area, here we have circumference. We can do here the same idea to solve the perimeter of the quadrilateral. Here we have a triangle. If you want to find the perimeter, you can add all sides. And if you want to find the area, you can use the area of the triangle A equal 1/2 multiplied by the base multiplied by the height. This is the base here, and this is the height here. You can find here the base. You can count the units: 1, 2, 3, 4, 5, 6, 7, 8. And the height you can count also here: 1, 2, 3, 4, 5. Then you can use here the rule: A equal 1/2 times 8 times 5 will be 20. 20 unit squared. And if you want to find the perimeter must to solve or to find the distance from B to C and the distance from B to A using this rule. To find the total of these links, to find the links of this side and the links of this side, and you know now the links of this side 8. So you can find the missing value of the two links here using this rule. Then you can add the all sides to find the perimeter. And also here the same idea, if you have quadrilateral, find the distance from A to B using this rule, then from B to C, then from C to D, then from D to A, using this rule. Then you can find the perimeter, you can add the all sides to find the perimeter. Then when you want to find the area, if you have this figure has all sides congruent, means you have square. So the area of the square will be S squared. Take the side, then do square to the side, you will get the area of the square. And if you have like this rectangle, the area of the rectangle will be A equal length times width. Length times width. This is width and this is length. This is inshallah the important ideas for this lesson. Who has any question about this lesson? Are all ideas clear for all?
Yes.
Okay. I will send to you the PowerPoint about the two ideas in this lesson. So try to see the record again, then study from the PowerPoint, then go to the extra practice to do training. Then you can check your answers from the answer of the extra practice. Then if you have any question, you can ask me inshallah in the next lesson. This is our period for today. Thank you for your listening. Have a nice day. Have a nice weekend. See you inshallah on next Monday. Assalamu alaikum wa rahmatullahi wa barakatuh.